下一位讲者是远道从东京而来，也是 Try Swift Tokyo 的主办人 Daiki Mazutake。他拥有14年以上的 App 开发经验，目前是从事新创到公共数位服务的各种专案。那今天演讲一样是用英文来进行。好，让我们用最热烈掌声欢迎我们国外的朋友 Daiki。
Hi, I'm Daiki from Tokyo, Japan, where I organize TriSwift, an international Swift conference. So it's my first time back in Taipei since speaking at the iPlayground in 2019. And I'm happy to reconnect with many friends from Taiwan. Thank you to the organizers for such a great event. So today, I'll talk about identity verification on mobile devices. People who are using identity documents issued by public authentication authorities, for example, this is my passport. It's an official document issued by the Japanese government that certificates who I am. With this, even here in Taipei, I can prove that I am Daiki Matsudate, born in January 31, 1991, and citizen of Japan. And this is Japan's My Number card, another official identity document issued by the government. On the surface, it shows my name, address, date of birth, gender, and identification number. But more importantly, it contains a tamper-resistant IC chip that securely stores this information along with 2 digital certificates. These certificates make it possible not only to visually check the card, but also to electronically verify my identity and even create digital signatures. All of these are called identity documents, and identity documents is used to uniquely identify a person. It must be issued by an authorized organization, and it typically includes a portrait and personal information, either printed on the card or stored in electronic method. Now, this is a scene from a Netflix drama called Tokyo Swindlers, which became a hot topic in Japan. In this story, certificate issued by a local government and a driver's license issued by the police office are used for identity verification. But in fact, there were fake documents created by swindlers. They even hired a homeless person to use a fake name and portrait as a property owner in order to sell a land actually not exist. This drama is fictional, but based on the true events. In reality, document forgery like this has been a serious problem in Japan. To prevent such crimes, we need stronger measures, such as using IC chips to electronically verify identity, not just checking the card surface. Against this backdrop, many countries began exploring ways to store driver's license on mobile devices. And in 2021, this effort was standardized internationally as ISO 18013 Part 5. When the MDL standard was created, several key features were introduced. First is selective data disclosure of elements. For example, if all you need to know, if all you need to know is whether someone is over 18 to buy alcoholic in store, there's no need to reveal their date of birth. Instead, the MDL can release only the elements that says age over 18. So next is cryptographic security. The MDL is structured in a format called CBOR, which pronounces CBOR. And the signature are encoded using COSE, which pronounces COS, which stands for Serial Object Signing and Encryption. Some of you may be hearing about CBOR for the first time. CBOR is a type of data format. It has a structure similar to JSON. But what JSON is expressed, CBOR is a binary format. Because of this, data encoded in CBOR is typically 30 to 50% smaller compared to JSON. This compact size makes the SIBOR especially suitable for IoT devices and mobile platforms, where efficiency matters and battery life can be improved. So there is also cross-platform interoperability. MDS can be used over NFC, BLE, QR codes, and the internet, so they work seamlessly across different platforms. The privacy is also a key focus. No data can be accessed without the user consent, which is enforced through biometric authentications like a Face ID or Touch ID. So based on this standard, Apple and Google have begun working with US states to store driver's license as MDLs in their wallet apps. Since driver's license in the United States are issued by each individual state, support differs depending on the state. In some states, they can use Apple Wallet, in others, Google Wallet, and in some cases, both. The standard for MDL was later expanded for more use with other identity documents. In 2023, this became standard as a mobile identity document, MDoc for short. For such as passports, insurance cards, and student IDs beyond driver's licenses, the feature is same as MDL. Using these two standards, our Japan enables the My Number card to be used on iPhones starting in June this year. This was made possible through collaboration between the Digital Agency, Government of Japan, and Apple. It's the first case in the world where national ID has been stored on Apple Wallet as MDoc. This card integrates both MDoc functionality and electronic certificates into a single device-bound wallet item. This digital credential adheres to global mobile ID standards as I mentioned. Apple can access the MDoc using APIs from Apple. This allows apps to request identity or age data within wallet, prompting the user consent. I won't go into the details of certificates today since it's specific to our local use cases. Instead, I'd like to show you how we can use Apple's API to retrieve an MDoc. The Apple provides 3 main APIs. Each is provided by the, also different contexts in app, in person, and in the web browser. So today I want to be covering the third one. This was introduced at this year's WWDC session. It allows you to request an MDoc directly from the browser, even without an iPhone. Check it out if you are interested. So let's start with Verify with Wallet. Verify with Wallet is a method for requesting an MDoc from wallet within your app. The retrieved data can then be used directly inside the app. Because of this, using this API requires a special entitlement for app. The data is encrypted in HPKE format, and neither Apple nor wallet can decrypt the information inside. Verify would, yes. There are 2 entitlements required to call this API. The first one is in-app identity presentment. With this entitlement, you must specify which documents you want to access. For example, US driver's license or Japan's national ID. You also need to specify which elements you plan to read, such as name, portrait, or age. If what you request at runtime doesn't match what you applied for in advance, the API call will be rejected. The other element, the other entitlement requires you to specify a merchant ID. This merchant ID is different from the app ID you use for Apple Pay or Apple Wallet. When you generate it from the Apple Developer Portal, you link it to bundle ID of the app. To use Verify with Wallet, Your app first calls the API and requests the user's approval. Once approved, wallet returns an object encrypted with HPKE. You then send this object to your own server where it's decrypted. After duplication, the payload is in CBOR format. And from it, you can obtain the elements you requested. The API provided by Apple is included in Passkit. In the descriptor, you specify the element you need. In the request object, you set the descriptor to and the region. At this point, you also configure the merchant ID. When you send the data request to the controller, the user sees a seed asking for permission to share the information. They will approve it with Face ID or Touch ID. Once the user approves, you receive an HPKE envelope, as defined in RFC 9180. This envelope combines a public key encryption with a symmetric encryption, providing a secure way to encrypt and decrypt the data. You then send this envelope to your server for decryption. When you decrypt this data, the resulting structure is CBOR. As you look into the data, you'll find that the given name field contains a value. This is the kind of data your app can then use directly. And that's verified with Wallet. The API you can use for in-app identity verification. For more details, please check out WWDC 22 session, What's New in Wallet and Apple Pay. I did go into details today about how to request entitlements, or how to test with a simulator or on devices. But you can find all of this explained in more details on Apple developers' website. So next, let's talk about ID Verifier API. This API uses two iPhones. The reader iPhone sends an MDoc request to the holder, and the user presents their iPhone in response. When the iPhone is tapped to the reader, NFC is used to initiate a BLE connection. Through this BLE connection, the MDoc is transmitted. The API provides two modes, display request and data transfer. With a display request, you can retrieve elements like a portrait, age, and name. For age, you can specify whether you want the actual age or just checking like over a certain age. The requested information is shown on screen only. Your app itself does not retrieve the data. No special entitlement request is required. As long as you enable the ID Verifier display capability in your app, you can use this feature right away. On the other hand, with data transfer, you can obtain additional elements such as date of birth, address, and sex on the top, the ones I mentioned earlier. Their elements are then transferred directly into your app. Unlike the display request, this mode lets your app actually access the data. That means you need to request a special entitlement from Apple called Proximity Reader Identity Read. The the ID Verifier API is provided through a framework called Proximity Reader. Compared to Passkit, it looks and feels like a much more modern API. Just like with Verify with Wallet, we specify the elements we want to retrieve. When we call prepare on the reader, we get the session needs for the request. Then we call the request on this session. The user is asked to present their ID by holding the iPhone for the reader. Next is the data request. It has almost the same as the previous one, but the difference is whether the requested information can be retained for a certain period of time. a small detail, but starting from iOS 26, we can use a protocol so that the calls can be more shorter. With a data request, the response is strongly typed, so you can retrieve the data easily. In most cases, using the reader requires issuing a token to authenticate the reader itself. This token is passed into the prepare method to be verified. So this is also raw data request. In addition to the standard data request, it handles the raw MDoc data, but there's no time to introduce you to at this time. I've shown you how to perform in-person identity verification using the ID Verifier API. For more details, please check out the WWDC 23 session, What's New in Wallet and Apple Pay. And just like with Verify with Wallet, details such as how to request entitlements or how to test are available from Apple developer website. So now in Japan, the digital agency has released the in-person verification app. This app uses ID Verifier API. Let's take a look at how it works in practice. So can I use a stand? Or somebody may help. Thank you. So there are two iPhones in my hands. This is a holder. Oh, sorry. So this is a holder which has my number card inside wallet. And this is a reader which installed the app to verify. So in the app, select the use case what we want to get from holder. Then tap start. The reader shows the UI to be tapped to the iPhone. The holder taps their iPhone on the top. Oh, sorry. Oh, certainly, my iPhone requires passcode. Sorry. What? Okay, this is my ID. And the user requests tap the iPhone here. The holder has requested authentication with Face ID. The reader shows the UI. And it says I'm over 20. That's it. So let me recap this session. So by using ID card inside iPhone, we can prove myself more secure and safety. And Apple provides three kinds of APIs for the situation: in-app, in-person, and web browser. ID Verifier for in-person provides three kinds of APIs: display, data request, and raw data request. And these APIs are compatible with the ISO standards. So we can use three APIs even if published by US driver's license or Japan's My Number card or some new ID card in other countries in future. So that's all. So it was happy to hear and see you again, and hope to see you in Tokyo next time. Thank you so much.
谢谢 Daiki 为我们带来这么精彩的演讲，还有 live coding 哦，而且他还特地把那个 slide 翻成中文。Thank you for Chinese slide. 亚萨西，哦，再给他最热烈的掌声，谢谢我们日本的朋友。好，那在午休之前，哦，又进入到我们无情的业配环节了。哦，3件事很快宣布。第一件事是，我们有提供盖印服务嘛？那今天盖印服务纪念印章的这个活动又升级了，我们有提供纸袋，哦，可以做自己的最特别的iPlay 官网的纸袋。好，那第二件事就是，我们的好朋友这个 RevoluK 的今天又带来很多这个礼品要给大家，不知道现在还有的话，我们等一下赶快去他们摊位逛逛，争取最后的这个纪念品。那第三件事是我们下午还有一场这个英文的 session， 那大家就是page后面再宣导一下，还是有那个 QR code 可以扫。那第一个连结是那个翻译的网站，或者说我们今年特地写的这个 iOS 的 App 里面也有翻译的这个功能，希望大家多多利用。好，谢谢大家。